In the early 1990s, the United States Air Force faced one of the most important procurement decisions in modern aviation history. At stake was the future of air dominance, an aircraft that would replace the aging fleet of fourth-generation fighters and ensure superiority well into the 21st century. Two prototypes stood at the center of this decision. On one side, we have the Northrop and McDonnell Douglas, who produced the elegant Northrop YF-23. On the other, Lockheed, Boeing, and General Dynamics, which produced the aggressive, highly maneuverable Lockheed YF-22. On paper, many engineers and analysts would later argue that the Widow was the more advanced aircraft. It was faster, stealthier, and optimized for the kind of warfare the world was clearly moving toward. And yet, the contract went to the YF-22, which would evolve into the F-22 Raptor, the most dominant air superiority fighter ever built. So what really happened? To understand this decision, you have to go beyond raw performance numbers and step into the mindset of military planners at the end of the Cold War. The competition was part of the Advanced Tactical Fighter Program, or ATF. The goal wasn't just to build a better fighter, it was to leap an entire generation ahead. The aircraft needed to combine four key capabilities: stealth, supercruise, advanced avionics, and high maneuverability. But the program never specified exactly how those qualities should be balanced. That ambiguity is what led to two radically different design philosophies. The YF-23 was designed around a single, ruthless idea: win the fight before the enemy even knows you're there. Its shape alone tells that story. Instead of conventional wings and tails, it used a diamond-shaped platform with a V-tail configuration. Every surface was aligned to minimize radar reflections. Its body was smooth, blended, and carefully contoured to scatter radar waves away from their source. But the real innovation was at the rear of the aircraft. Instead of traditional circular exhaust nozzles, the YF-23 featured long flattened exhaust troughs. These spread out the hot engine gases over a wider area, allowing them to cool more rapidly before mixing with the surrounding air. The result was a dramatically reduced infrared signature. In practical terms, this meant heat-seeking missiles would struggle to lock onto the aircraft. Combined with its already exceptional radar stealth, the YF-23 was designed to be nearly invisible across multiple detection systems. Then, there was speed. The YF-23 demonstrated superior supercruise performance compared to its rival. It could sustain supersonic speeds without afterburners more efficiently, giving it greater range, lower fuel consumption, and a reduced thermal signature. This wasn't just about going fast. It was about staying fast, staying hidden, and controlling the engagement. Everything about the YF-23 pointed toward beyond visual range combat. It was a predator, built for the first shot, the first kill, and total disengagement before the enemy could respond. It wasn't designed to dogfight, because ideally it would never need to. The YF-22, by contrast, was built around a more balanced and arguably more conservative philosophy. It embraced stealth, but not to the absolute extreme of the YF-23. Instead, it invested heavily in agility. Its most defining feature was thrust vectoring. Unlike conventional engines that push thrust straight backward, the YF-22 nozzles could pivot, redirecting engine force in multiple directions. This allowed the aircraft to perform rapid pitch changes, tighter turns, and extreme high angle of attack maneuvers. In a close-range dogfight, this capability was decisive. The YF-22 could outmaneuver nearly any opponent, even at low speeds where traditional aerodynamic control surfaces lose effectiveness. This gave it something the YF-23 lacked: dominance in a visual engagement. While it was still stealthy and capable of beyond visual range combat, the YF-22 was built with the assumption that not every fight would go according to plan. It was designed to win even when things went wrong, and that assumption is the key to understanding the Air Force's decision. At the time, beyond visual range combat was still evolving. Missile technology had improved significantly, but it wasn't considered fully reliable under all conditions. Electronic warfare systems could jam radar and confuse targeting systems. Rules of engagement often required pilots to visually identify targets before firing, especially in complex or politically sensitive environments. And history, from Vietnam to more recent conflicts, had shown that dogfights still happened, even when technology suggested they shouldn't. The Air Force couldn't afford to gamble everything on the idea that long-range engagements would always work perfectly. They needed a fighter that could dominate across the entire spectrum of combat. The YF-23 was optimized for the future. The YF-22 was prepared for both the future and the uncertainty of the present. But the decision wasn't purely about combat philosophy. There were deeper, less visible factors at play. One of them was technological risk. The YF-23 advanced stealth shaping and exhaust system were highly innovative, but that innovation came with uncertainty. Manufacturing, maintenance, and long-term reliability posed questions that hadn't been fully answered. The YF-22, while still cutting edge, relied on technologies that were considered more mature or easier to integrate into a production aircraft. Then there was demonstration strategy. During the fly-off phase, the YF-22 team made a deliberate effort to showcase the aircraft's agility in dramatic fashion. High-performance maneuvers were clearly visible, impressive, and easy for decision-makers to understand. The YF-23, on the other hand, focused more on data-driven performance, stealth metrics, thermal signatures, and efficiency. But stealth is invisible by nature, and invisible advantages are harder to sell. Finally, there was institutional confidence. Lockheed had already proven its ability to deliver stealth aircraft with the F-117 Nighthawk, the world's first operational stealth jet. That track record mattered. Northrop, on the other hand, had struggled with the B-2 Spirit bomber's costs and production delays. The B-2 was so complex that its price tag ballooned to over $2 billion per aircraft. By the time the Advanced Tactical Fighter contract was being decided, the Air Force was traumatized by Northrop's budget overruns. When they looked at the YF-23, they didn't just see a fast jet. They saw the potential for another B-2-style financial disaster. They trusted Lockheed because the F-117 was cheap and simple compared to the B-2. When billions of dollars in national security are on the line, decision-makers tend to favor the team they trust to deliver on time and on budget. Lockheed won because they played it smart by using the trust they earned from the F-117 to convince the generals that the YF-22 was a sure thing. In the end, the choice wasn't about which aircraft was superior in isolation. It was about which aircraft best matched the Air Force's needs at that moment in history. The YF-23 was, in many ways, ahead of its time, a machine built for a world where stealth and long-range engagements would dominate completely. The YF-22, however, offered something broader. It combined stealth, speed, and agility into a single platform that could adapt to any combat scenario. It really paints a picture of a brother who was too smart for his own good, losing out to the brother who knew exactly how to talk to the parents. But why didn't they use both, some may ask? From an engineering maintenance perspective, supporting two different stealth airframes at the same time is a logistical suicide mission. The Air Force didn't have the money to sustain two fifth-generation programs. The engineering trade-off here is that they had to pick the multi-tool. They decided that if they could only have one jet, it had to be the one that could do everything: stealth, speed, and high maneuverability dogfighting. The F-22 checked all three boxes, whereas the YF-23 prioritized stealth and speed above all else. In addition, because Northrop was already building the B-2 Spirit, the government was actually afraid of a monopoly. If Northrop had won the YF-23 contract, they would have owned the entire U.S. stealth fleet. By giving the win to Lockheed, the government ensured that two different engineering firms kept their stealth skills alive. It was a strategic decision to keep competition healthy for the future, even if it meant the better individual jet lost. The story of the YF-23 and the F-22 is more than just a tale of two aircraft. It's a lesson in engineering trade-offs. Because in military design, better is never absolute. Every advantage comes at a cost. And the real challenge isn't building the most advanced machine. It's building the one that wins the war you might actually have to fight. Was the YF-22 actually the best decision, or did the Air Force make a terrible mistake? Drop your thoughts in the comments below. Thanks for watching. Remember to like and subscribe, and we'll see you in the next one.